Good, let's unpack this. Close your eyes for a second and picture the stunning coastline of South Pelion, Greece. You see the villages clinging to the hillsides, the olive groves, the beaches. It's beautiful, right? But what about just below the surface? Because lurking there, often unseen by, a casual observer, is a surprisingly vibrant underwater world.
And what's truly fascinating, I think, is how much of this hidden life, particularly the corals, thrives in relatively shallow areas. We're talking often between just 1 and 20 meters deep. The source material we're diving into today is this brilliant guide focused specifically on the marine biodiversity of South Pelion. It really shines a light on the incredible array of coral species you can encounter right there.
Exactly. And it's not like a super dry scientific text. It's meant to be a practical resource, designed for anyone spending time near the water, snorkelers, divers, even just curious beachgoers. It's built to help you identify what you're seeing and, crucially, understand how to interact with this, well, fragile ecosystem responsibly. So our mission in this deep dive is basically to pull the most important insights from that guide, helping you understand the diverse corals of South Pelion, how to spot them, why they're so important, and the simple steps you can take to help protect them.
And South Pelion provides such a rich tapestry for this exploration, doesn't it? You've got the more exposed, rocky reefs along the Aegean coast, constantly getting hit by wave action. Then, tucked away, are these sheltered submerged caves and overhangs near places like Demochari, Kostri, Pagasetic. These are like little secret gardens for soft corals. And you can't forget the gentler sloping bays and sandy bottoms, particularly over in the Pagasetic Gulf, where life often clusters around scattered boulders.
Yeah, it's not uniform at all down there. It's more like a mosaic of different conditions. And the water itself plays a big role. Seasonal temperatures swing quite a bit, from maybe a cooler 12 degrees C in winter up to a pretty balmy 27 degrees C in summer, while the salinity stays pretty consistent around 38 PSU.
PSU.
Oh, right. Practical salinity units. It's basically parts per thousand of salt. So, a typical healthy, salty Mediterranean environment.
Right, so you have these dynamic conditions supporting this hidden diversity. Which brings us neatly to the first big insight from the guide, understanding what you're actually seeing down there. While the Med doesn't boast those massive barrier reefs, like in the tropics, it has its own unique and surprisingly rich coral life, often overlooked, actually.
And the guide really helps demystify it by breaking it down. It says you'll mainly encounter two categories. First, the hard or stony corals. Think of these as the architects, maybe, the engineers of the underwater world.
Yeah, that's a good way to put it. They build these calcium carbonate skeletons, which makes them rigid, and they contribute to the reef structure, even if it's on a smaller scale here compared to, say, the tropics.
Okay, so hard corals are the builders. What's the other type?
Then there are the soft corals, as the name implies. They don't have that hard, rigid skeleton. They're flexible, they sway gracefully with the currents, and they have a more leathery or gelatinous feel if you were able to touch them, which, spoiler alert, again, you definitely shouldn't.
Good reminder. Always worth repeating. And the guide notes a third group that can look very similar, especially in the Mediterranean colonial anemones. These apparently get mistaken for soft corals quite a bit because the individual polyps look pretty similar.
They really do. The key distinction, as highlighted in the guide, often comes down to their internal structure and how they attach. True soft corals form this connected colony structure. It's called a coenenchyme, whereas anemones are essentially individual polyps just living very close together. So to tell these groups and the specific species apart, you really have to train your eye. Become a bit of an underwater detective, focusing on certain visual clues.
Like coloration, for instance. The guide points out this amazing range. Bright yellows, oranges, deep purples, earthy browns, all sorts. But here's a key trick it mentions. Remember that color changes underwater. Reds and oranges disappear first as you go deeper. So that really vibrant coral might look kind of dull or gray unless you shine a light directly on it.
That's a great point. Shape and growth form is another huge clue. Are you looking at a massive dome-shaped structure that looks a bit like a brame? That could be Cladochora chyspetosa. Or maybe a tiny solitary cup tucked into a crevice, like Bulinophilia europaea. It could be thin, encrusting mats spreading over a rock that's Clavularia crassa, or maybe thick, fleshy lobes branching out like Alcyonium palmatum, so many forms.
And you should pay attention to the tentacle arrangement, too. Are the polyps those tiny, sort of flower-like feeding parts extended and visible? Are they out during the day or only maybe at night? Some colonial species, the guide says, only open at specific times, so checking back later can be useful.
And crucially, where are you seeing it? The substrate and habitat tell you a lot. Does it prefer a shaded crevice, a vertical wall, or is it out on an open ledge exposed to more light? Corals are often very particular about their address,
Yeah, makes sense. And as the guide notes, if you could touch them, which again, please don't, texture and rigidity would be an obvious difference. Soft corals feel pliable, while stony corals are literally hard as rock.
Yeah.
So, yeah, observation is everything here.
Precisely. Knowing what features to look for is step one. The next piece of the puzzle, as the guide lays out so well, is figuring out where and how to actually find them.
Right. So the guide tells us that in South Pelion's coastal waters, most of the interesting coral action is happening between, let's see, 1 and 30 meters deep. Their exact location is heavily influenced by things like how much light gets down there, how much the water is moving, and of course the temperature.
And this means different species really do call different places home. For instance, you're much more likely to stumble upon Balænophilia europaea or maybe Clavularia crassa in those shallower, well-lit areas where sunlight penetrates easily.
Okay, shallow and bright for those two. But what about the shadier spots?
Ah, well, if you explore shade walls, overhangs, or maybe the entrance to caves, that's the preferred turf for species like Alcyonium palmatum or those brilliant yellow carpets of Parazoanthus axonella.
Gotcha.
And deeper. Venture a bit deeper, maybe onto ledges or under larger overhangs, and you might find the solitary cups of Caryophylla inornata or the lesser-known Hoplongia durotrix. It really is about knowing their preferred neighborhood.
The guide also gives really practical ID tips tailored to what you're actually doing in the water. So if you're snorkeling, it says to focus on the species you can easily see in shallow water. Things like the encrusting Clavularia crassa, the solitary orange Balænophilia europaea, or that bright yellow Parazoanthus axonella carpeting the rocks. Having a waterproof guide or even just a small slate with some notes is apparently a lifesaver.
Definitely. For divers, you obviously have the advantage of more time and depth. Use a torch that's absolutely key for seeing the true colors, especially in deeper or shaded spots. Spend time looking closely at the overall growth form. And if you ever get the chance to do a night dive, well, that's prime time. So many polyps are extended and actively feeding after dark. It's a different world.
Oh, cool. And for all you photographers out there, your camera is an amazing identification tool. Get close with a macro setting to capture details of the polyps or the colony structure. The guide even suggests photographing the same coral at different times of day to see how its appearance changes, like with polyp extension.
Good tip. Now, even with all these pointers, distinguishing some corals can be genuinely tricky. They can look quite similar sometimes. So the guide has some solid advice for when in doubt. The simplest, most valuable thing is just to take photos. Get good, clear shots from different angles if you can.
Right. Then you can compare those photos with guides or online resources later on. Or even better, share them. Share them with local experts or marine scientists. Apparently, they love seeing what people are finding out there.
Absolutely. And this is where you, yes, you listening, can become a citizen scientist. It's really important. Crucially, when you take those photos, try to record the details. The GPS location, if you have it, the depth you saw it at, and any environmental conditions. Was the water clear? Was there a strong current? Stuff like that. This information isn't just for your personal logbook. It's actually valuable data. It helps researchers track species distributions, understand habitat preferences, and monitor the overall health of the ecosystem over time. Every sighting you record contributes.
That's so cool. Just paying attention and taking a picture can actually turn you into part of the research effort. Okay, let's get a bit more specific now and meet some of the individual coral characters that the guide highlights, the ones thriving in South Pelion's waters.
Absolutely. Let's start with the hard, or stony corals. The guide introduces us first to Cladocora caespitosa, often called the cushion coral. Now, this one is particularly significant in the Mediterranean because it's one of the few species that actually forms colonies substantial enough to kind of act as a reef builder.
A reef builder in the Med. Wow. How does it look?
It grows into these dense, dome-shaped structures, usually a sort of yellow-brown color, and you'll find it in sheltered, rocky areas down to about 30 meters or so. The guide notes that its individual polyps are quite large and pretty easy to see, especially if you look at night when they're fully extended.
Okay, cushion coral. Got it. What's next?
Then there's Balænophilia europaea, the pig-tooth coral. Now, unlike the cushion coral, this one is solitary, just a single polyp living in its own little cup. It's typically a vibrant orange or reddish color, and it loves to hide away in shaded rocky crevices or under overhangs, often right there in the shallower areas. Pretty common.
Ah, the orange solitary one. Okay. And another solitary one mentioned is Caryophylla inornata, the carnation coral.
That's right. It's small, with a very distinct, quite delicate cup shape. And it has pale, almost transparent tissue, sometimes with faint stripes. Very elegant looking. It has a strong preference for vertical rock faces and dimly lit spots, so it's often a favorite find for more experienced divers who know where to look.
Hmm. Sounds like a challenge to find.
It can be. Now, the guide also points out a species that has a slightly different story, Oculina patagonica. This one is actually considered an alien species in the Mediterranean. It originally comes from the western Atlantic.
An alien species, so it doesn't belong here originally.
Exactly. In South Pelion, you'll spot it forming these irregular clumps with white to pale yellow polyps. It's often found in shallow waters, frequently near harbors or sites that have been disturbed by human activity. It's definitely something researchers are monitoring closely because of its potential impact on the native species. Competition for space and resources.
Interesting. So it's a reminder that not everything down there is necessarily a long-term resident. The guide also gives quick mentions to a couple of others, right? Polycythus muelleri
Yep, that's a small colonial coral that's pretty cryptic, easily overlooked.
and Hoplangioduratrix.
Another colonial species, a bit lesser known, with a slightly more upright growth form. You might find it if you look really carefully in the right spots.
Okay, so that's a taste of the hard corals. What about the soft ones?
Right. Shifting gears to the soft corals, one of the most visually striking ones, especially if you find a whole patch, is Parazoanthus axinella. It's often called the yellow cluster anemone, though remember our earlier point about the technical distinction between anemones and true soft corals.
Yes, the colonial anemone, technically.
Mm-hmm.
But it looks like a soft coral.
It does, very much so. It forms these dense, really bright yellow carpets on rocks, particularly on vertical walls or under ledges. And its polyps are usually extended during the day, which is a bit unusual, and they sway beautifully with the currents. Very photogenic.
Unlike many corals that are night owls. And it often lives alongside sponges or gorgonians, right?
Yeah.
Creating these vibrant underwater scenes.
Exactly. Really beautiful. Next up is Clavularia crassa. Now, this one is often mistaken for algae at first glance because it forms these thin, encrusting mats that just spread over rocks.
Oh, so easy to swim right past it.
Very easy. Its polyps are typically gray to purple, and they wave gently in the currents. That gentle waving is a key identifier once you actually look closer.
Got it. Look for the waving. And finally, the wonderfully named Alcyonium palmatum.
Dead man's fingers. Yeah, great name. It grows in these thick, fleshy, finger-like lobes, usually a soft pinkish to orange color. You'll find it on shaded rock walls or under overhangs, and its texture is distinctly pliable and fleshy compared to the hard corals. You can really see the soft aspect.
Okay, dead man's fingers. I'll remember that one.
So even just scratching the surface with these examples from the guide, you can see there's a surprising variety. Shapes, colors, life histories, all playing out in South Pelion's coastal waters.
Definitely. But the biggest question, I suppose, is why does identifying and understanding these seemingly small creatures matter so much? Especially in a place like South Pelion, where they aren't forming massive reefs.
That's where their ecology and importance really come in. The guide strongly emphasizes this. These corals, even the ones that don't build huge structures, play a vital and often underestimated role in the marine ecosystem. They're not just pretty sights. They're functional, essential components.
How so? What are their main jobs?
Well, first off, they act as crucial biodiversity hubs. Those complex structures, whether they're rigid stony skeletons or swaying soft coral branches, create loads of microhabitats. They provide shelter, hiding places, and breeding grounds for countless other marine creatures. Think juvenile fish hiding from predators, crustaceans scuttling among the branches, mollusks finding a place to attach. It's like a little underwater city centered around the coral.
Ah, okay, so they're like apartment buildings for other sea life.
Kind of. They can even offer some protection as natural breakwaters, helping to dissipate wave energy, though, perhaps on a smaller, more localized scale here compared to giant reef systems. Still important locally.
And they're involved in the chemistry, too.
Yeah, they are active participants in the ecosystem's chemistry. They contribute to nutrient cycling through their symbiotic relationships, like with those tiny algae we mentioned earlier, and just through their interactions with the surrounding water and other organisms. It's all connected.
And the guide mentions their indicator species. What does that mean exactly?
It means the health of the coral colonies is like a report card for the surrounding marine environment. If you start seeing signs of stress, like bleaching or die-offs, those are critical warnings. They signal broader problems, maybe pollution, rising water temperatures, or ocean acidification. Watching the corals tells you about the whole system.
Right, so they're like the canaries in the coal mine for the sea.
Exactly, and the guide makes a really good point. While their physical scale in South Pelion might seem modest compared to, say, the Great Barrier Reef, Their ecological contributions in their local context are absolutely significant, and, as the guide puts it, often disproportionate to their physical size. So, conserving these habitats isn't just about the corals themselves, it's fundamental for supporting the entire web of marine life, for bolstering sustainable ecotourism, and preserving the unique natural heritage of the region.
Which brings us directly to what you, the listener, can actually do about it. The guide offers really clear, actionable advice on responsible practices when you're in the water. Your behavior has a direct impact on these sensitive organisms.
Absolutely. And the number one rule, honestly, it's worth repeating again: never touch, stand, or rest on corals. Even a gentle brush can damage their delicate polyps and that protective mucus layer they have. Just don't touch.
Okay, rule one, no touching. What else?
Opt for reef-safe sunscreens. This is a big one. Many common sunscreens contain chemicals like oxybenzone that are known to be harmful to marine life, including corals. Look for mineral-based ones like zinc oxide or titanium dioxide, non-nano if possible.
Good tip. Check your sunscreen ingredients. And for divers,
If you're diving, practice and maintain neutral buoyancy. This means you float gently above the bottom, not bumping into things. It especially means keeping your fins up and away so you don't accidentally kick sand onto corals or break fragile pieces. Control is key.
makes sense. And it should go without saying, really, but avoid feeding marine life and definitely don't take anything dead or alive as a souvenir. A photograph is the best souvenir, right?
Absolutely. The guide also adds some more practical tips, like do your buoyancy checks in sandy areas before you swim over any coral zones. Try to choose dive or snorkel operators who clearly prioritize conservation in their practices. Ask them about their policies, and maybe even join organized beach or underwater cleanups if you get the chance. These simple actions are your direct positive impact on the environment you're enjoying.
So beyond just being careful yourself, the guide really highlights the incredible potential of citizen science. You, as someone observing the underwater world, can become a crucial part of the conservation effort. It's not just for scientists anymore.
Exactly. You can record observations, use platforms like iNaturalist, SeaWatcher, or MedObies. There are apps and websites for this. Log the species you identify, noting where and when you saw them. Every little bit helps build the picture.
And photograph the corals. Always try to include the date, location, and depth in your notes, or even the photo's metadata if you can. This visual record is invaluable for tracking populations over time.
So important. And crucially, report anomalies. If you see anything unusual like corals looking pale or white, which could be bleaching, or maybe widespread die-offs, or a species you suspect is invasive spreading really rapidly, or unusual amounts of algal overgrowth smothering corals, document it with photos and details and report it. You can report it to local marine authorities, research institutes, or conservation groups.
Who should we report to? Any specific groups?
The guide suggests engaging with NGOs like Reef Check Med. They often organize monitoring programs that volunteers can actually join. This collective, long-term monitoring by citizen scientists gives researchers absolutely essential data. It helps them track changes over years, identify emerging threats early on, and then develop effective strategies to protect these habitats. It's a powerful way to turn your passion for the ocean into meaningful action.
That's brilliant. So your holiday snaps could actually help save the corals. Now, despite the resilience of some species and these crucial conservation efforts, there's a significant global threat that also impacts corals in South Pelion: coral bleaching.
Yeah, this is a phenomenon you've likely heard about, unfortunately. It's often linked to warming oceans. Basically, coral bleaching happens when corals experience stress. Most commonly, the stress comes from elevated water temperatures, but pollution can also trigger it. In response to the stress, they expel the tiny, colorful symbiotic algae called zooxanthellae that live within their tissues.
Ah, the zooxanthellae. And those algae are incredibly important, aren't they?
Hugely important. They are like tiny solar panels living inside the coral. They use sunlight to produce energy through photosynthesis, providing the coral with essential nutrients, basically, most of its food. And they also give the coral its vibrant color.
So when they're expelled,
When they're expelled, the coral tissue becomes transparent, revealing the white skeleton underneath. That's why it looks bleached. And worse, the coral loses its main food source and becomes much more vulnerable to disease and ultimately starvation and death if the stress continues.
okay, so heat is the main stressor. What else causes bleaching?
The primary trigger globally is definitely temperature stress. Even just 1 or 2 degrees Celsius above their normal comfortable maximum temperature, if it lasts for a few weeks, can stress corals to the point of expelling the algae. But other factors can contribute or make it worse. Things like excessive solar radiation, especially in very shallow, calm waters during hot periods. Pollution from land-based runoff, like agricultural chemicals or sewage, can stress them. Sedimentation from coastal construction or erosion can smother corals or block sunlight. And also, ocean acidification, caused by the ocean absorbing excess CO2 from the atmosphere, makes it harder for corals to build and maintain their hard skeletons in the first place, making them weaker overall.
And how can you spot bleaching? What are the signs?
Well, the most obvious sign is the coral visibly losing its color. It
Oh.
looks pale, white, or sometimes eerily translucent. You might also notice the polyps are retracted and not showing their normal feeding behavior. And over time, if the bleaching is severe or prolonged, you might see a general decline in other marine life that depends on that coral habitat. The whole little ecosystem suffers.
Has this been seen much in South Pelion?
The guide notes that while South Pelion hasn't experienced the truly massive reef-wide bleaching events seen in some tropical regions, thankfully, isolated incidents have been reported. Where? Often in the Aegean parts of Pelion during particularly hot summers, especially in sheltered bays with low water circulation where the water can really heat up. Also, sometimes in very shallow tidal pools during heat waves, those can get extremely hot. And occasionally in areas with high boat traffic or near outfalls where water quality might be locally impacted, adding to the stress.
So it's more of a localized issue there, but still a warning sign that underscores the fragility. But even here, you can take action, right, if you see potential bleaching.
Yes, if you see corals that look unusually pale or white, record those sightings. Use citizen science platforms, there are specific ones like Coral Watch, or you can add notes to general observations on iNaturalist, specifically designed for reporting bleaching events. Photos are key.
Okay, report it. What else?
It's also probably wise during peak summer heat waves to maybe avoid swimming or diving directly over very shallow coral zones during the hottest part of the day. The water there might be particularly stressed, and you don't want to add any extra disturbance.
Makes sense. And obviously, continuing to use those eco-friendly sunscreens we talked about helps minimize any additional chemical stress.
Definitely. And then, on a broader scale, the most impactful action we can all take is working collectively to reduce our carbon footprint.
Yeah.
Slowing climate change is absolutely crucial for reducing the frequency and severity of marine heat waves globally. That's the primary driver of these mass bleaching events worldwide.
It all connects back. But the guide leaves us with a crucial note of hope, though, which is important to mention.
Yes, it does. Corals can recover from bleaching if the stress factor, usually the heat, subsides quickly enough. If temperatures drop back to normal or pollution levels decrease, they can gradually reabsorb symbiotic algae from the surrounding water, or the few that remain can multiply. And they can regain their color and health, sometimes within weeks or months, assuming they haven't been too badly damaged.
So it's not always a death sentence.
Not always. And looking forward, restoration projects, things like coral gardening, growing coral fragments in nurseries and transplanting them, and placing carefully designed artificial reefs to provide new habitat, these are actively being explored and implemented in parts of the Mediterranean to help boost recovery and resilience.
It's good to hear. There's active work being done.
Yes, the threats are definitely real, but dedicated conservation efforts, community involvement, and informed action from everyone who enjoys the ocean can and really do make a difference.
So we've really taken a deep dive today, haven't we, into this source material, exploring the often hidden coral world thriving just off the coast of South Pelion. From understanding the basic differences between hard and soft corals, and how to identify specific species by their shapes and colors.
To appreciating the absolutely crucial ecological role they play, which goes far beyond just being pretty underwater decorations.
Yeah, and we've highlighted how your visit, your observations, your actions, they can be a positive force, both through practicing responsible behavior when you're in or near the water, and by contributing vital data through these citizen science initiatives.
It's easy, isn't it, to look at a coastline like South Pelion's and only see the beauty above the waves, the villages, the trees, the beaches. But take a moment to consider that incredibly diverse, living world thriving just below the surface.
Think about how delicate it is, perhaps more than we realize, and how your simple act of looking closer, understanding what you're seeing, maybe using that guide, practicing responsible behavior, and even just sharing what you learn, how that can contribute directly to the survival of these hidden gems and, contribute to the ongoing story of marine conservation in this really special part of the world.
Absolutely. It connects us all to that underwater world.
So maybe the final thought for you listening is, what surprising detail did you learn today that makes you want to look a little deeper, a little closer next time you're near the coast?